Every time a plane goes down, a quiet but extraordinarily precise machine kicks into gear, and most people have no idea how it works. Today, we are breaking down exactly what happens after an aviation accident, from the first alert to the final report, and why the system built around it has made flying one of the safest ways to travel on Earth. Let us start with the organization at the center of it all. The National Transportation Safety Board, or NTSB, is an independent federal agency. It is completely separate from the airlines and separate from the regulators who oversee them. That independence matters enormously. According to the NTSB's own published process, the agency is charged by Congress with investigating every civil aviation accident on U.S. soil, as well as accidents involving U.S. registered aircraft over international waters. Since its creation in 1967, the agency reports it has investigated more than 153,000 aviation accidents and incidents. That is an almost staggering number, and it tells you that this is not a reactive agency. This is a permanent, always-on institution built around one core mission: figure out what went wrong and make sure it does not happen again. Now, here's something important to understand right from the start. The NTSB does not assign legal blame. It does not fine airlines or prosecute pilots. Its entire focus is on determining the probable cause of an accident and issuing safety recommendations to prevent the next one. According to officials, the NTSB considers those safety recommendations to be its primary tool for preventing future civil transportation accidents. Keep that in mind as we walk through the process, because every step is designed around that single goal. So what actually happens in the hours after a crash? It begins with the NTSB's Response Operations Center, known as the ROC, which monitors information sources, including traditional media and social media, around the clock for reports of aviation incidents. The moment an accident is confirmed, investigators are notified and a GO team is assembled to travel to the crash site. For major accidents, that GO team can be on scene within hours. According to reports, a full GO team may include experts in structures, power plants, that means engines, aircraft systems, maintenance records, air traffic control, meteorology, human performance, survival factors, aircraft performance, metallurgy, and both the cockpit voice recorder and the flight data recorder. That is not a handful of people. That is a full forensic army, each specialist focused on one specific dimension of what may have gone wrong. At the scene, the first priority is securing evidence and preserving what investigators call perishable data, anything that could degrade, disappear, or be altered. According to reports, this includes photographing wreckage and terrain, mapping debris fields, and recording observations that will assist later reconstruction. Investigators examine aircraft structures, systems, and components for evidence of damage, malfunction, or failure. In some cases, the wreckage is moved to a secure facility so components can be examined in a more controlled environment. Investigators also typically review maintenance logs, inspection records, airworthiness directives, and any documentation that may reflect the condition of the aircraft before the accident. But perhaps the most famous and most critical piece of evidence in any aviation investigation is what most people call the black box. In reality, according to aviation experts, there is no such thing as a single black box. There are two separate devices. The first is the Flight Data Recorder, or FDR. The second is the Cockpit Voice Recorder, or CVR, and both are required by law on commercial aircraft. Contrary to the name, these devices are actually painted bright orange, not black, to make them easier to find in wreckage. They are built to withstand extreme conditions: powerful impacts, intense post-crash fires, and deep underwater pressure. The Flight Data Recorder continuously captures technical performance data about how the aircraft was operating. According to FAA regulations, modern recorders must capture at minimum dozens of parameters, and solid-state recorders can track hundreds or even thousands of data points collected multiple times per second. That means investigators can reconstruct almost everything about how the aircraft was behaving in its final moments: speed, altitude, heading, engine performance, control surface positions, and much more. The Cockpit Voice Recorder, on the other hand, captures audio from inside the cockpit, conversations between pilots, communications with air traffic control, and even ambient sounds from the aircraft itself. According to reports, CVR audio is legally protected under federal law, meaning the NTSB cannot release actual cockpit recordings to the public, only official transcripts. The transcription process is painstaking. Reports indicate it can take a full week just to transcribe a single 30-minute recording. A group of accredited representatives, including airframe manufacturers, pilot unions, and engine manufacturers, collaborates to ensure the accuracy of every word. Once the recorders are recovered, they are transported as quickly and securely as possible to the NTSB's laboratory in Washington, D.C. If a recorder has been submerged in water, officials say it is kept immersed in deionized water during transport to prevent corrosion, which is one of the biggest threats to the stored data. At the lab, specialists examine the recorders and determine whether the data can be extracted. An undamaged recorder can often be downloaded normally. Damaged recorders require more intensive work, and according to reports, specialists may need to transfer data chips into specialized devices that prevent further data loss while allowing a safe download. Now, here is the part that many people overlook. While the Go team is on scene and the lab is processing recorders, other specialists are simultaneously gathering information from entirely different sources. According to the NTSB's published process, this includes collecting flight logs, reviewing maintenance records, and conducting personal interviews with air traffic controllers, ground crew, maintenance personnel, and in some cases, survivors. The investigation runs on multiple tracks at once, because in aviation accidents, the cause is almost never one single thing. It is almost always a chain, a sequence of events, decisions, mechanical states, and environmental conditions that lined up in a specific and tragic way. The agency also uses what it calls the party system. This allows the NTSB to designate outside organizations, airlines, manufacturers, unions, regulatory bodies, as official parties to the investigation. Those parties provide technical representatives who work alongside NTSB investigators. This is a serious responsibility. According to published accounts from organizations that have been through the process, party representatives must be experienced, composed, and cooperative, and they must represent their organizations with total honesty. The NTSB, according to its own guidelines, remains in charge at all times. Party status is not an invitation to shape the narrative. It is an obligation to contribute technical expertise. So, how long does all of this take? According to the NTSB, a preliminary report covering the basic facts of what happened is typically issued within a few weeks of an accident. But the full investigation, including the all-important probable cause determination, generally takes 12 to 24 months. Complex cases can stretch well beyond that. The agency notes that factors like the scale of wreckage, the number of parties involved, and the need for specialized testing can significantly affect the timeline. The NTSB will not determine the cause of an accident while on scene. That statement alone tells you a great deal about the rigor of the process. They will not rush to a conclusion in front of cameras and grieving families. They will follow the evidence wherever it leads. When the analysis phase is complete, a team of specialists writes a draft report that includes a description of the accident, a review of the investigative analysis, and a determination of probable cause. That report is then brought forward, depending on the complexity of the case, either for director-level approval or to a full public board meeting for adoption. Once adopted, the final accident investigation report is prepared and released to the public. Every word in that document is sourced to evidence. Every finding is traceable to data. And then comes the most important part, the safety recommendations. According to the NTSB's own records, the agency has issued over 15,500 safety recommendations since it was established in 1967. Those recommendations go to the FAA, to airlines, to manufacturers, to pilot unions, to airports, to anyone with the authority and ability to act on them. The NTSB itself has no power to enforce those recommendations. It cannot mandate changes. But according to historical data, approximately 73% of the recommendations it has issued have been adopted in whole or in part by the organizations they were directed to. That adoption rate is a testament to the agency's credibility. The real-world impact of those recommendations is significant. According to transportation safety records, NTSB-inspired improvements have included the development of mid-air collision avoidance technology, the installation of ground proximity warning systems, airborne wind shear detection and alert systems, smoke detectors in aircraft lavatories, and fuel tank safety improvements. Ground proximity warning systems alone have saved lives by alerting pilots when an aircraft is dangerously close to terrain. These are not minor tweaks. These are fundamental changes to how aircraft are built, how pilots are trained, and how the entire aviation system is managed. It is also worth noting what the NTSB is not. According to legal experts, the NTSB does not determine civil liability. Its findings and its probable cause determinations are specifically excluded from being used as evidence in civil litigation, though its factual findings often inform and shape the legal proceedings that follow. There is a legal firewall built between the safety investigation and the courtroom, precisely so that the pursuit of truth is not contaminated by the fear of liability. Internally, the NTSB handles about 1,200 aviation accidents and incidents per year, according to its own published figures. Not every one of those gets a go team. Resources are scaled to severity, but every single one gets investigated. Every one gets a factual report, and every one has the potential to generate a safety recommendation that could prevent the next accident before it happens. Looking ahead, aviation safety experts and the NTSB itself have identified areas where the system continues to evolve. Ongoing discussions, according to reports, include the expansion of cockpit voice recorder duration from 2 hours to 25 hours on newly manufactured aircraft, a change already adopted by international regulators, including the European Union Aviation Safety Agency. There is also continued advocacy for crash-resistant flight recorder systems and broader implementation of safety management systems across more categories of aviation operators. Flying is, by the data, extraordinarily safe.
And it is that safe, in large part, because of a process that treats every accident not as a tragedy to be managed, but as a puzzle to be solved and a lesson to be learned. The next time you board a flight, the safety features protecting you, the training your pilots received, the warnings built into the cockpit, a remarkable amount of that traces back to investigators who showed up at a crash site, gathered evidence with painstaking care, and asked one relentless question: what exactly happened here, and how do we make sure it never happens again? That is the NTSB. That is how air crash investigation works. If you found this breakdown useful, follow the channel for more deep dives just like this one. Every day, we break down the systems and stories that shape the world around you.